Okay guys, hello everyone. As usual, I'm trying to re-record this session because I experienced some recording issue with the last session. That's why I'm recording the lab again for you guys. So now our objective, as usual, you can see the objective is 1, configure the host name of R1, switch 1 and switch 2, configure the appropriate IP address on R1, PC1, PC2, PC3 and PC4, manually configure the speed and duplex on interface connected to other network devices, configure appropriate description on each interface, disable interfaces which are not connected to other devices, and the last objective is to save the configurations. So now, as we can see here, by default, routers, switches, when you first have access to the CLI, they come with a name, especially for router, it comes with router. When you reach to the switch, it comes with switch, the name, the default name. So we need to change these names because if you don't change the names, during some configurations, you cannot able to do some certain configuration, especially for an example. Now if you want to create SSH in this router, if the name is in that default format, you cannot able until you change the router from the default name to any other name you prefer. Same apply to the switches. So now we need to change these names. We need to apply the IP address. As you can see, we already know what is an IP address. This is a one network, and this here R1 here will act as a default gateway. Example, let's say all these PCs, they want to communicate outside. Let's say we have an internet connected to this router. If they want to communicate, they need to use this IP address to communicate outside. So now the other one, we need to manually configure the speed and duplex. Now one thing you need to know, this gigabytes run at 1000 megabytes per second, so we need to make sure that this interface, this G0/0, the speed, let's say, because gigabytes operates with 1000, this side is supposed to be 1000 and this other side is supposed to be 1000, and they need to communicate at full duplex. When we say we have what we call half duplex and full duplex. Half duplex, example for half duplex devices is a host, is a hub. A hub is a example of a half duplex. Now with a hub now, let's say if the hub is connected to this router here now, when routers say hello, the router needs to send all the information before the hub communicates. But in full duplex now, router can send the packet and at the same time the switch can reply simultaneously without waiting for any other side. So that's the difference between a half and a full. So it's encouraged now to implement full duplex because we expect our devices to communicate simultaneously without waiting for any other device. So now we talk on the description, configuring descriptions. Let's say for an example now, R1, you can add a description that this G0/0 is connected to SW1, which is switch 1, and in switch 1 you can add G0/1 is connected to R1, G0/2 is connected to switch 2. It's very, very essential. G0/1 to G0/2 is connected to end device. It's very, very essential, especially when you are doing troubleshooting. You will be able to do troubleshooting very easy because you have already added descriptions to these switches. Now the fifth option here is disable interfaces which are not connected to other devices. For example now, R1 here, we only using G0/1, meaning other interfaces are there, G0/1, G0/2 that we are not using. It is encouraged, it is advisable for us to disable these interfaces, because if you just leave that interface that way, you understand? Let's say you have a faceplate. The faceplate is in the downstairs, wherein you connected a PC. The hacker can just come on this and disconnect that faceplate, connect the hacking PC to that particular faceplate downstairs because you are not using it. What will happen? the person will have access to your network. That's why if you are not using a interface in any network device, make sure that you disable that interface. Same applies to switches. Switches have a lot of interfaces, so when you are not using, as you can see, you are only using 4 interfaces here: G0/1, G0/2, and the 1 and 2. So all the others, 24 ports, we are not using it. You see? So now you need to disable these interfaces so that someone cannot just have access to these interfaces. And at the same time, we save our configuration. So now let's start. What we will do, we try to, if we are configuring R1, all the necessary stuff in R1, we need to do it all in R1 before we move to the next device, so we can save time. Now click on R1, go to the CLI. As you can see, by default it's R1. We need to change the name. We say enable. From enable now go to config T. In config T, you already know how to move between the prompts, the enable, the privilege mode, the configuration mode, the interface mode. We have already done that. If you are new, please make sure that you check the previous videos. We have already covered all this. In here now we say host. The host name is R1. R1, press enter. From here, what? We want to assign this IP address to R1. So you can see, this is our network we are using. We say IP address. Say IP address. I love writing it in lower cases. IP address 192.168.10.254. Our subnet mask is /24. Our prefix length is /24. So we say 255.255.255.0. Yes, guys, learn something. You see, when we execute this command, it's a invalid input dictated. Yes, because we didn't go into the interface. Take note, when you are in this global configuration mode, for any changes you want to do to this interface, this G0/0, we must be in G0/0 interface. Now let's say we say interface. The command is interface G0/0 because we want to assign IP address to this interface. If we press enter, now I can even use this upper arrow key to recall this command if I don't want to type this command again. If I press enter, you see the prompts have accepted it now. So from here we add description. The description connected to SW1. We have added our description, and what I think the duplex, we say duplex or we say speed. Let's start with speed. The speed is supposed to run at 1000, and duplex, the duplex is full. Press enter. So there is some caveat with, you see, when we say the duplex is full, this interface went down. In real devices, when it says this interface full, this is supposed not to go down. If you go down, it's supposed to automatically come up. In packet tracer now, until we come to this other device and make this other device full also, we implement the command speed 1000, duplex full, before both up can come up. As we implement, you can see the differences. So now we say full. What do we need to add again here? We say this interface, say no short, no shut down. We have told the interface to go up, but still the interface is down because we need to configure the other side. So now let's, as always, after doing your work, we try to verify. We can end this. We say show IP interface brief. With this command, we can see the changes we have implemented. Now, as we can see, you can see that we have assigned IP address on this interface, which the status is up, but the protocol is down, meaning we need to tell this interface implement the same configuration from this side so that both the protocol will be up. As we see, we can see that we have the G0/1 and G0/2, but routers by default they are administratively down. So we don't need to configure or disable on routers because they are administratively down. So but in switches you need to disable them. Definitely you need to disable them. So let's have an example now. If we say we still you want to see how the commands work in router, we can go into the router. Now we say these two interface, we want to implement the command to disable this two interface. This is G0/1 and G0/2. The interface will implement interface range because this is two. When it is two or more, you try to range the interfaces. Interface range G0/1 to 2. Under this range now we say short. We can now say short down. See? So if we execute the same command, do show IP interface brief, you see the interface is still down. They are all still down. So you don't need to implement that command in routers, but in switches it is a must. You need to implement them. So now let's verify. Let's run our config. Let's see the changes we have made. You can still be in this interface range and execute show run, but you need to implement do show run. With the command do show run, you can see the changes you have made. You see in G0/0 what changes. Our description is connected to switch 1. We assign IP address which is 192.168.10.254 with the side annotation of /24. We can see the duplex is full, the speed is 1000. So you see, now you can see this interface G0/1 is down and also /2 is down. So now we need to save our work. From here, let's say end. If you end now, it will take the prompt will take us to the privilege mode. From here you can save your work. We have different way to save our configuration, our running config, because this is the running config. We need to save this running config to startup config because we want the next time when we reboot this router, it will come up with this latest configuration we have done on it. So we say copy running config to what? Startup config. You can implement this command, copy running config to startup config. Or we can just say WR. With this WR, it's the same thing. We have saved our work in R1. Now we'll go to R to switch 1. From switch 1, click on the CLI. Let's try to enlarge this so we can see it clearly. You see by default the switch is switch. We need to enable config t host name is SW1. What do we need to do? Our second option is what? We go to this interface. The interface G0/1 interface. We say speed. The speed is 1000. Duplex is full. We're supposed to see this other interface both supposed to go up now. As you see now, because both interfaces are now running at the same frequency, see what is happening in packet tracer. Both will now come up, but in real device you don't need both sides supposed to be up and running. So now from here, now we jump into G0/2. Okay, we need to add description for this G0/1. We say description connected to R1. This is connected to R1. We have added our description, and what now we say G0. Let's go into interface. If you want, you can be in this G0/1 interface and jump into G0/2. You don't need to exit. But if you are just practicing, learn to exit so that you cannot misconfigure. So the best practice is to exit out. But if you are already familiar with the command the command line, you can still be in that and execute the command interface G0/2. You go straight to G0/2. So for now we have exit from that interface. Now say interface G0/2. Press enter. Now say what? Speed. The speed is 1000. Now we are now in this G0/2 interface. The speed is 1000 and duplex is full. Duplex is full. Let's see. This side now is supposed to go down. You see, as you can see now, because we have implements. Until we implement the same command here, both this command and interface will come up. So now we say connected description for this. The description connected to SW2. Now we can see this G0/1 and G0/2. Now let's exit from this interface. Let's range. We need to range interface range F0/1 to 2. These two interface F0/1 to 2. Now we say the description for these two. Connected to end host. Connected to end host. They are connected to end host. So now we need to execute a command. A command to see the interfaces in the switch. The command is different from the one we execute in the router. In the router we say IP, show IP interface brief. In the switches we say show interface status. You see, the command is different. As you can see now, in this switch, in switch 1, we have the F0/1, F0/2 up to F0/24. But as you can see, these two are connected. 1 and 2, they are connected. Now we can see connected to end host. Even during troubleshooting, I find it very easy because you have already added a description to this. But now all these others. Now see this. If you see, you can see that from R1 side, from this switch 1 to R1 side, it says here full and running at 1000. You see, but in real device you cannot see this A automatic. You only see full and 1000 in real devices. So now we need all these are all ports functioning, because by default they are all functioning right now. If you connect a faceplate now, if any of these interfaces are connected to a faceplate that is not using, let's say in right downstairs, so that people have access to that particular platform, someone can just connect to that faceplate and have access to your whole internet, your whole network. So to avoid that, we need to disable from F0/3 to 24. So now to disable this F0/3 to 24, we need to go into the global configuration. Now interface range, we need to range it. Range F0/3 to 24. we say shut. Command is shut down. As you can see, now we are seeing having a prompt telling us that this interface are administratively down. So let's verify. We say do show interface status. You see, this is pretty good now. Now we have disabled these interfaces. So even someone try to connect now, the person will not have access to your network because these are all disabled. Only the interface connected to a network device that is running, they are now connected. So from there, now we say what? Let's add description to these interfaces. We can add a description. Not in use. Easy description. Not in use. From there, what next? We need to disconnect. All is set, as you can see. So now we go to switch 2. We need to save this. Let's just use the shortcut method. With this, we have saved our work. Now we move to switch 2. Switch 2 now, we need to go to switch 2. The CLI. We need to change the name from enable config t host name sw2. Now we need to have access to which interface? G0/1. G0/1 interface G0/1. The speed. The speed is 1000. Duplex is full. Now supposed to see the interface supposed to turn on now. You see? They are now turning up. So from here we see what? Description. Let's add description. Description connected to switch 1. They are connected to switch 1. So now we need to show, we say we need to range exit now. Exit. Now we say interface range. Interface range. Interface range F0/1 to 2. Don't get confused. You can use cap or lowercase. Doesn't matter. It's not the prompt is not command case sensitive. You can use either uppercase or lowercase. It all work. Now see interface range F0/1 to 2. Now from there we say this. We add description. Description connected to end host. End host. They are all connected to end host. Connected to end host. So now we say, have we added for yes description for switch 1 connected to S1? Okay. This the F0/1 and 2, they are connected to end host. Now let's show and see the interfaces. Now we say show interface status. Show interface status. Show interface status. Let's see the interfaces. See, they are all up and running. Now we need to disable these interfaces. As you can see, these two are connected to end host, and we need to disable F0/3 to /24. Now we need to range them. Interface range F0/3 to 24. This command learn something else. This command, we're executing this command in the privilege mode. This command is supposed to be in global configuration mode. So we move, we say config T. Now we are in global configuration mode. Now if we recall this command now with the upper arrow here, now let's just type this. We say interface range. Interface range what? F0/3 to 24. Now you see we are in the range. Now you can say shut down. Shut down. Now we add description to this interface. Not in use. See? Now you can see if we execute the command, when you are in the interface range mode, you need to use the word do. This do can execute a command for you to see what you want to see. Do show interface status. Now you can see I'm in the interface range command, but I can still able to execute a command there to see, to show. Now we can see now F0/3 not in use, disabled. All this in switch 1, in switch 2, we are in switch 2. G0/1 which is connected to switch 1, but this G0/2 is not connected anywhere. I can go into interface G0/2 within this command without exiting, because I already know that if I implement interface G0/2 and press enter, I will move from this range to interface G0/2. But if you are not familiar with this, make sure that you just exit this interface. Exit, then you type interface G0/2. Now you see, I'm no longer in range, but I'm now in this G0/2. Now I can say disable, shut down. See? So now if I say show, do show interface status, what will happen? We can now see the G0/2 is now disabled. You see? So now let's execute the show run command. Do show run. See? All the configuration changes. Interface G0/, as you can see, interface G0/1, description connected to end host, /2 is connected to end host, /3 is not in use, not in use, not in use, blah blah blah. See all this. Now let's say what next do we need to do in this interface. Thing connected, yes, all done. Now say end. Now can WR to save the running config for startup config. Now from here, what's next? I think this is what we need to do now. To configure IP address in R1, we have done that. Now we need to assign IP address to PC1 to PC4. Click on PC1, go to config. Always take notes to write the default gateway IP address. This IP address, we need to write this is default gateway. Now we say the default gateway now is the IP address was assigned to this router. The PCs need to use it to communicate outside, like an internet. They want to communicate outside to the WAN, to the internet. They need to pass through this. Now we say 10.254. This is the gateway. So now we need to assign the 10.1 now on this PC. So you come to the fast Ethernet. On fast Ethernet now, say here, click on IP address. I just want to paste the default gateway that I copied. I will just backspace the 254, which is this, then assign .1 to save time. Now with packet tracer default, when I click the subnet mark, which is 255.255.255.0, when you click, automatically packet tracer will fill last side. So I've done with switch 1, PC1. Now go to PC2, same thing, config, paste our default gateway, which is 192.168.10.254, this IP address here. You know, we already have the 192.168, so I just write 10.254 so don't get confused. We paste our default gateway, go to the fast Ethernet, we paste the default, backspace .2 here, PC2 10.2, you can see it here. Click down, automatically packet tracer fill in the /24 subnet mask because this 192 is a class C. So packet tracer definitely know when the IP address starts with 192 is a class C, and the prefix length for /C is 255.255.255.0. Go to PC3, same thing, go to config, paste the default gateway, paste the default gateway. Now go to fast Ethernet, paste. This is PC3. Can even see the name up here. PC3, we say .3. Click down, subnet mask, fill. Now go to PC4. We implement the same thing. Default gateway. Paste the default gateway. Go to the fast Ethernet. Implement the same thing. Now say PC4 is .4. Now press the same subnet mask here. From there, what will happen? Close. Now we need to test. Do a testing now to see if the lab is up and running, is operating, if what the configuration will do is in effect. So now from PC1 here, let's try to pin PC4. Click on PC1. Go to the desktop. Command prompt. Now we say 192.168.10.4 PC4. We need to add pin. We just type the number. We need to add pin, P-I-N-G, pin what? 192.168.10.4. See, bingo, the pin is successful. Now let's say from PC1 side, let's try to pin our gateway here. Our gateway is pin 192.168.10.254. Press. You see, the pin is successful. The pin is successful. So now let's try to pin from other device. Let's say from PC3 now, I want to pin the gateway and PC2. Click on config, go to desktop, command prompt, pin 192.168.10.254. See, the pin is successful. You can get a reply from from .254. Now let's from PC3, let's try to pin PC2. I can recall the command backspace 10.2. See, all successful. So we want to see this in action. Let's say PC3 is pinning this gateway. We want to see how the traffic is moving from PC3 to the R1. You can click on simulation. That's why Packet Tracer is a simulation software. Now from here, you can click on PC3. Recall our previous command, pin, let's say 254, pinning 10.254, this IP address 10.254. Now press enter. From enter now, we need to see an ICMP packet. This is an ICMP packet. Now we press next to see how the packet is being moving within our network. Switch 2 to switch 1, switch 1 to R1. We need to get now an ICMP reply from here. See? Now to switch 1 back, switch 2 back to switch 3. So guys, this lab is successful. So in our previous session, there was an issue with the recording, so I tried to do this, to redo it again for you guys just to have access to this lab. Thank you very much. Let's keep on learning, keep moving forward, don't discourage, prepare yourself for opportunities. Thank you very much. My name is Ibrahim Ali Kama as usual. Have a wonderful day. Thank you.